Hey there, so in this video I'm going to briefly show my game All-In Fighter, and I'll also be showing how the lag compensation works. So these two simulator windows here are going to connect to each other over the network, not over the computer. So it's actually the data is actually being sent to a remote server and coming back to the other client. So first of all, I'm going to connect. The menus obviously are not very good looking, but it's just for the concept for now. So there's a matchmaking system where I can both find a game, and this guy is trying to find a game, and then now this guy is trying to find a game, and they see each other, and one guy clicks to start, another guy clicks to start, and we're both in. So the person on the left is this little smaller guy here called Davis, and you can see right now that the ping is actually considered really bad by my own standards. We basically want under 200 or maybe even under 150 for a smooth multiplayer play. So there's going to be a lot of lag because the ping is quite high. But the most important issue that I'm trying to solve here, number one, is that both clients, both versions of the game, player and opponent, have the same exact simulation. So the character should always be at the same positioning. So right now you can see they are at the same positioning because I have my lag compensation algorithm. It's not really complicated, so I wouldn't really call it an algorithm. What happens when I move my guy on the left? I'm controlling the guy on the left here, and when I move, my opponent's version of me, which is this guy here, moves as well. And I think it's my computer is getting kind of laggy right now. So when I move, my opponent's side of the code helps me move to my exact position. Every time I stop moving, I need to keep moving until I reach the same position that the actual character is in. So I move this guy will keep moving until he reaches where I'm actually at right now. And it shows here that you need to catch up, like from 261, that was lagging quite badly. So this guy would be at 261 x coordinate wise if he wasn't catching up, and he needs to move to 277.79. And these numbers are all rounded up, but I'm just showing them here exactly. If I didn't round them up, then in the checking function of the algorithm, I would always be lagging, and I don't want that. I want my lag compensation to only check if my characters are out of sync. If they're not out of synchronization, then I'm not going to check, or else it's going to waste system resources, memory, whatever. So I have this caught up notification when I'm actually caught up. So right now the ping is quite bad, which is actually quite good to showcase this function. So this might break, and this will probably break if I try to do too much at once. Like say, if I try to move again before my character on the other side on the opponent's screen has actually caught up. So let's see. I don't know if it's the console, the black windows with all this text generated here that's causing a lag. But yeah, see, there's a bit of, I ran into something called an overshoot. I actually ran a bit too much forward, so I had to go back, and that's kind of ugly, but whatever. That's second priority for now. Yeah, see there, I overshoot again, which means usually in most cases I fall short of where I'm supposed to walk to. If I'm supposed to walk 100 pixels, I usually end up walking 90 pixels because of the variation in the latency and the lag. But in some cases, in some weird cases, I might actually walk over by 10 pixels, and I have to compensate for that, and sometimes it's going to look quite bad. And of course you might be wondering why I don't just keep synchronizing the character's actual position. What happens when that happens is that the movement becomes extremely choppy. So right now you can see that the movement is smooth on both screens, besides the fact that my computer itself might be lagging. So same for both characters. Kind of laggy, but you know, it works. And you can see that both characters will end up at always, hopefully always, to end up at the same position, X and Y. So that's my game as of now. Thank you.